Good morning. So, we will continue from where we finished in the last class. A little bit, of course, additional thing I will just tell you. This calculation we did in the last class, we did this calculation in the last class, remember, and that is where we stopped actually. Then I was looking at celestial, sphere and spherical trigonometry, we will come to that. But just before that, I wanted to tell you about solar equation of time, right, because anything, our angle is always calculated with respect to the solar time, right. So, clock time plus there are correction for longitude and there is a correction for there is another small correction for time, exactly time. So, there is first one, longitude correction is 4 into local longitude minus standard longitude. Why? Because longitude is also whole of the surface of the earth can be divided into 360 angles, degree angles, and in 24 hours earth covers 360 degree. So, this 360 degree, since time is related to rotation of the earth, therefore, 24 hours corresponds to 360 degree, 1 hour corresponds to 15 degree. So, 1 degree corresponds to how much? 1 hour 60 minutes corresponds to, so 1, yeah, that is right. So, 1 degree will corresponds to 4 minutes. So, therefore, local longitude minus standard longitude 4 minutes basically, because 1 hour is 60 minutes corresponds to 15 degree. So, for 1 degree 4 minutes, that is what it is. And there is some corrections, there is some correction that is given by, this correction is given by this one. So, that is what it is. So, this is sometime we will be using this, or we may not use this, we might be more directly using this, but supposing you want to convert it from standard time, clock time for any country or any region, then you convert this to solar time. This generally we neglect, this part we neglect, right, this generally we this will depend upon the day of the year, as you can see from here. This is something to do with the day of the year. So, again 365 is corresponding to 360 degree angle. So, that corresponds to day of the year, because there is some variation with respect to day of the year, essentially because of distance of the earth is not same from the sun every day. So, related to that, but we can neglect this part, we can just calculate with respect to this. Okay, so, let us go back to our celestial triangle and celestial sphere and spherical trigonometry, which is required to relate altitude and azimuth angle to declination. As we said in the last class, sun's position is governed by altitude angle and azimuth angle, right. And these two angles, that is sun's position, is dependent on location on the surface of the earth, which is given by latitude of that location, day of the year, that is given by declination, and time in the day is given by hour angle. So, altitude angle is a function of all these three, and relationship between altitude angle and this, I can straightway give you the formula, but I thought I will also tell you about the basic principle behind it, so that it it remains in your mind more easily. So, that can be derived, this relationship between altitude angle and those three factors, hour angle, latitude and declination, can be derived through principle of spherical trigonometry. Similarly, azimuth angle can also be derived, all other angles are derived based on those principles. So, I will just quickly discuss this principle. So, a celestial sphere, which I was last class also we just mentioned, repeating this, celestial sphere is a concentric with the earth and its radius can be arbitrarily chosen as large as desired. So, for example, this you consider this, this is a celestial sphere. Now, this is the center of the earth, this center of the earth, this is center of the earth, right. So, this point is the center of the earth, and this circle or circular plane is parallel to the horizontal surface. So, I conceive a diametrical circle at the center of the earth, and this diametrical circle is parallel to horizontal surface at some point, right. So, this will be the vertical, then this will be the vertical. Earth might finish somewhere here, because I said the radius can be arbitrary, right. So, this will be the vertical, because horizontal is this is the horizontal, right. In the horizontal I have north, south, east, west. So, if from the north if I go clockwise I go to the east, and follow further I go to the south, and there is west, right. Now, equator, equator will be somewhere here, this was equatorial plane. So, this is horizontal celestial sphere with center as the center of the earth, celestial sphere with the center of the earth. This earth is not redundant, so I just corrected it here, and diametrical plane of the celestial sphere parallel to horizontal surface, this is not looking nice. So, I just not readable, so I just made it this. So, this is parallel to the horizontal at that particular location. Normal to this is vertical. So, I have the center of the earth and a circle parallel to the horizontal at the center, perpendicular to that will be vertical. So, this is vertical. Equator will be somewhere there at certain angle, right, and the sun will rise from east and go towards the west. So, sun path is shown by the dotted line, So, that is a kind of a celestial sphere. Now, I can define certain angle here, I can define all those angle here, because angle between the sun's ray and the equator is declination, and angle between sun's ray. So, this is the sun's ray, sun position is, as I said, dotted line following. So, it is here right now. I join with the center of the earth, and this is horizontal plane. So, therefore, this angle is the altitude angle. Join the sun ray at the center of the earth, and since this is parallel to the horizontal plane, this will be altitude angle, right. And angle between sun's ray and the angle between sun's ray and this equatorial plane will be declination. We will come to that in a little bit later. And projection of the sun onto the horizontal surface is this, from geographical north. If I take clockwise azimuth angle, then this is the azimuth angle. So, you can see that, but it is not necessary that all the time I take horizontal surface as a diameter. Only thing is that earth center and center of the celestial sphere should match. So, according to my convenience, I can choose the diameter and then create, define the spherical triangle and then derive. So, let us see, let us go further. So, coming back here, you see this is my equator. This time I have done equatorial plane as the equatorial plane as a center of the earth, and equatorial plane is a diameter, not horizontal, just is the equivalent. Earlier one I just did, I said horizontal plane, this is the equatorial plane. So, this I have my choice. So, here for my convenience what I do is this is my equatorial plane, right, that is the diameter. So, this P, P would represent what? North pole. If it was horizontal plane, then it would have been vertical. Here this will represent the north pole P, because normal to the equatorial plane will be north pole, somewhere the polar direction. Surface, this point is on the surface of the earth. So, if I draw a line from the center of the earth to the point on the surface of the earth and beyond, so this is the surface normal to it, that is basically vertical. That is basically vertical, right? That is basically vertical, right? So, this is north pole, this is vertical, this is vertical. So, the point and center of the earth, if I join and extend it, it will be always normal to the sphere. So, this is vertical, right, and this is my location, let us say somewhere location projected into the celestial sphere. So, this is north pole, this is vertical, this is equatorial plane, and what will be then latitude? This angle will be the latitude, AOC would be the latitude, angle AOC will be latitude, AOC would be latitude. If the sun's direction is like this, then its projection is onto the equatorial plane is this much, and then that will be delta. So, I can define angles, the way I take the plane. I can take different plane at the center of the earth as diameter and then define various angles. So, here I have defined delta. As you can see, this is nothing but the latitude, because OC is the projection of OA here, and sun's ray is BO. So, its projection is OD, therefore, BOD is nothing but delta, right, and it's it's basically with the this is the vertical. So, this is angle OAB represents actually zenith angle, right, sorry OB or same thing OAB, because this vertical to the sun, that is basically zenith angle. So, our angle will be now this, you see when 12 noon sun is aligned to north south, sun is aligned to north south. At any other time the hour angle I can define. So, it would actually be aligned to the, it will be the line joining the north pole, sun will be at 12 noon, sun will be at the north pole and it will be joining the north pole, and this it's in, I mean basically it is the highest altitude at that point of time. So, it connects the north south line. So, it will be joining this, sun position will be joining this point, this point, sun's position will be somewhere there. So, our angle I can define from here actually. So, our angle, see, therefore, this is the center of the earth, AOB is the zenith angle, as I said, AOB is the zenith angle, and our angle is defined with respect to 12 noon position, where this is the north pole and its projection onto the earth. So, this is at 12 noon, any other time sun will be somewhere there, and that is the hour angle. So, at 12 noon sun direction will be something like, it will be almost it will be matching with somewhere along in this plane, sun's ray will be there. So, at any other time it would be moving. So, our angle can be so this is delta, this is our angle. So, our angle will be 12 noon north south direction coincides with the sun's position is on the north south plane, north polar to. So, basically from polar to the equatorial plane, it will be actually on that itself. At any other time it will shift and our angle is defined like this. So, this is how we can define all the angles. So, this is written here actually, I already explained to you. O is the center of that, the point A represents the location under consideration, point A represents the location under consideration, so that you can read it and understand it, and thus OAN is the vertical direction of A. So, O this is the OAN is the PP is this is the vertical direction, OAN is a vertical direction, OAN is the vertical direction, that is what is stated here, is the vertical direction at A. OB is the direction of the sun rays. So, OB was the direction of the sun rays at that point of time, OB is the direction of the sun rays. So, you come back again, OB is the direction of the sun rays at time of consideration, thus angle AOB is the zenith angle, that is what I just explained. So, angle AOB will be zenith angle, because this is vertical, this is the sun. So, angle between vertical and sun's ray, that is zenith angle, right. So, that is how we define. A is the zenith angle, that is 90 degree minus altitude angle. OD is the projection of sun ray on the equatorial plane as shown. So, DOB is the declination angle. So, that is what I explained, DOB is the declination angle, all right. So, this diagram is explained through these statements. Now, point P represents north pole, continuing with that. So, angle BOP is thus, what is this angle? Angle BOP, this is north pole, right, this is the sun's ray. So, angle between sun's ray and equatorial to pole, what is this angle? The 90 minus declination. Angle between equator and sun's ray is declination, and north pole is normal to the equator. So, this is 90 degree minus declination, 90 degree minus delta. So, basically the angle BOP or POB is nothing but delta, that is what is being said, 90 degree minus delta, BOP is thus 90 degree minus delta. AOC is the latitude angle, because AOC would be latitude angle, again going to this, AOC will be latitude angle, this is my location, this is equatorial plane, this latitude angle. So, this angle AOP or POA, whatever you call it, this is 90 degree minus latitude. So, this angle is 90 degree minus latitude. What is this angle? Zenith angle, 90 degree minus 90 degree minus beta, right. And what is this angle? 90 degree minus delta, 90 degree minus delta, because this is delta, sun's ray to the equator, and if you connect a ray and a pole to the sun's position. So, this is 90 degree minus delta, this is 90 degree minus beta, and this is 90 degree minus latitude angle. So, right, these three arcs. Now, a spherical triangle, as I said, I mean spherical triangle, so by definition this is what it is. So, arcs AB, BP and PA lie on the great circle, on the celestial circle, therefore, they form what is called spherical triangle. A spherical triangle is, if this my drawing is okay, this is a sphere, right. So, any arcs lying onto the, this might be my center. Oh, my drawing is not all that good, that is why I is not drawing it. So, from the center I draw one arc, another arc, and there is a third arc between these three. So, spherical triangle, there are three planes actually. One is covered by one of the arcs, this arm, another arc, three arcs. They must lie on the same circle. So, this is one, this is another, and the third one is a bigger one. And then there are in between angles, right. There are in between angles. So, that is what is a spherical triangle, that is what is a spherical triangle. So, there are three arcs essentially, three arcs. If this is my radius, this is my radius, this is one, this is another, and the angle between these two is the other, and contained angles are these angles, right. Now, relationship between these angles can be found out from principles of spherical trigonometry. Let us see what are those. So, this I just said. Okay. Now, at 12 noon plane POCA coincides with the plane PODB. At 12 noon POCA, that is basically line joining the pole to the equator, right. This is projection, this is OC is this, OC is the P is the point, this is the location point. So, this vertical plane, sun will be coinciding with this at 12 noon, because it is right at the top, right at that, it is a maximum altitude. So, the maximum altitude would be this. So, this is where it will be coinciding with this, but other time it will shift. So, our angle come into picture, other time it shifts and our angle will come into picture. Thus, angle at P thus represents the hour angle. Angle at P represents the hour angle and is same as COD. So, our angle is same as COD. Let us see what is COD. Go back. COD is the hour angle. This is our angle. This is our angle. This is our angle. This is delta. This is our angle. So, the delta would have been, it would be, the sun would have been here, but now somewhere it is there. Earlier it is in the eastern side actually it is showing. So, so this is what represents the hour angle. Hour angle we always write in terms of absolute term, 12 minus, I mean the hour minus 12, whichever is the difference, absolute value we take. So, it is here. So, this is the hour angle. If it was on this side, still absolute value we take. So, this is our angle. So, basically at 12 noon it will coincide with the line joining north pole and its projection onto the equatorial plane, because 12 noon is the time corresponds to declination is defined with respect to that. So, any time, any other time it will be shifting, right. So, one consider, okay, now how do we find out? We should find out relationship between the, so the the one can consider vectors and let their magnitudes be unity. So, in spherical triangle what we do is, let me just so this was the triangle, this was a spherical triangle as I said, and these are the arms, right. This is, so what we do is we consider unit vector along this direction, unit vector along this direction. For example, this is OP, so OP vector, this was I think OA, so OA vector, and this is OB or whatever it is. So, unit vectors we consider, that is their magnitude is unity. What we do is we take, so if we take the cross product of these two vectors, what will I get? Cross product of these two vectors, cross product of two vectors are the magnitude of each one of them into sine of the angle, included angle. So, sine of the included angle is this. So, you can see that this is nothing but this arc, right, this arc. Similarly, if I am interested in this included angle, then I will take cross product of this vector with this vector again back, right. So, I will get this angle, and if I take dot product of these two, it will have cos of this included angle, right. So, first I take unit vector, therefore, value is not important because radius I am taking unity. So, it will all whatever be the. So, that will go away. So, I will have OP vector, OA vector, and I think I called it OB, is it? OB maybe. Okay. So, OB vector, each are unity. So, if I take cross product of OP and OA, then I get a vector which is normal to this plane. Similarly, I take cross product of OB and OP and OB, I get a vector normal to it, and dot product of these two will give me the cos of included this angle, because they are normal to both of these, they will make same angle as those two planes are making. So, this is exactly what we do. Let us see the understanding between thus with this direction normal to the plane of POC. Similarly, with direction normal to the POD, the dot product of these vectors would involve cos of our angle h. Now, what was our angle? We defined that this was our angle, if you recollect. This here, this was our angle. My spherical triangle is this is my spherical triangle P, B, and O, and the angle, this is nothing but the our angle, because this is the angle between this plane and this plane. So, that is the our angle. So, cos of our angle, cos of our angle will be involved when I take vectorial products as they are, vector products of vectors as they are. So, you can see that OA OP I said dot OB OP, and included angle is our angle. It was like this, if you recollect, another one was like this, and another one was like this. Now, the angle between these two, their projections nothing but this is our angle, because we said the sun ray will coincide or it will lie in the plane joining north pole and equator, north projection of the north pole onto the equatorial circle. So, it will lie on that plane at 12 noon, any other time it will be deviated by our angle. So, included angle is our angle, and that is what it is. Now, remember this was how much OA OP will be the angle between OA and OP. OA, angle between this one, the angle between this and this what was this angle? This is the north pole P, and this was A location. So, this is 90 degree minus, this is A is the location here, and this is B. So, this is 90 degree minus latitude. With the north pole it will be latitude. When it is the sun, it is 90 degree, minus, in this case 90 degree minus delta, because equatorial plane the angle is delta. So, this is OB OA OP sine of this, and sine of between OB and OP, which is nothing but 90 minus delta, cos our angle. So, this cos L, cos delta, cos our angle, right. So, this product is, we can find out in this manner, cos latitude, cos delta, cos our angle. Now, this one is nothing but I can also find out from another process, another way, taking what is called triple scalar product, principle of in vector algebra, if you look at it, triple scalar product. So, using concept of triple scalar product, if I write this as q, let me write a single vector q, I will write it like this. So, I am writing this dot q, this is a cross and this is a dot. So, when you combine this is called scalar products. This will be from, you can derive this, look into anywhere, you will find it out also. It will be given as OA OP into cross q, OA dot OP cross q, this dot can change. So, this is equivalent, and this I leave it like this, this I replace q, because q was nothing but q I defined as q was what, OP into OB, OP cross q is nothing but OP cross OB. So, principle is this, in my case q is nothing but, because if you remember this was the case, this is I am writing as q. So, q is OP cross OB, I just place it back again here. So, this is it. Now, this is triple vector product. So, using principle of triple scalar product, I can write it like this. Using principle of triple vector product, I can express it, I can expand this actually, this product OP cross OB cross OP, right. And yeah, this is what it is, this is what it is. So, erase this now. OP is, so the vector triple product is OP dot OP minus, so this is a, you know, this vector product is given by OP dot OP from vector algebra. I could have derived it, but I didn't do it. You can look into any one of them, any one of the, you know, you just search net, you will get it. Triple vector product, you will get it, or triple scalar product. So, it's given as OB bar, I mean OP dot OP vector and OB vector, you know, this is the formula. OP dot OP dot OB minus OP dot OB dot OP. So, this is how it is. So, this is basically, you know, OP dot OP is how much? Is 1, because cos 0 1. So, this is nothing but OB. Dot product of the vector on the same vector is cos 0 1 and unity vector. So, it is 1. So, this is OB, and what was this OP and OB between this cos, you know, OP was north pole, B was the sun. So, 90 minus delta, and OP bar, what is OP bar? What is OP bar? What is OP bar? What is OP bar? This is, yeah, OP bar is unity simply. So, this I can write as, you know, OB bar. So, this would be written as OA, OP, OB, etc., etc., will be written as cos delta, etc. So, finally, it will turn out to be cos 90 minus delta, and OB bar is the angle, unity multiplied by the angle will be there. So, this comes out to be sin beta minus, because 90 minus beta sin delta cos 90 minus. So, this is what it is. So, so this would be this I can now equate with my formula that I had, cos latitude cos delta cos hour angle is equals to sin beta minus sin theta sin latitude. So, I am interested in this altitude angle. So, I can express this sin beta is equals to sin declination sin latitude plus cos latitude cos declination into cos hour angle. In general, this expression you know, it's, if A is the arc angle, B is the arc angle, included angle is AB, then sin A sin B, because this came because these are all 90 degree, 90 minus, that is why they came as cos here, cos AB is equals to cos of C, the third angle, and cos beta cos, you know. So, this again B and A. So, any three in a spherical triangle, you will find this relationship will be valid. If this is my A angle, this is my, you know, this is A angle, this is the three angles, this is the contained angle AB between, this is B and this is C. So, there are three angles representing these three arcs, contained angle I call it AB angle. So, this sine of A, this angle, sine of this angle, and cos of included angle is equals to cos of this arc angle minus cos of this angle again and cos of A angle again. So, this is a general relationship, this is general relationship. Okay. So, I think we just stop for a minute, and then we'll, you know, we'll start from the next one, right. So, we'll start from the next one, look for in general principle related to this.